Alright, our fifth lesson in this unit is arithmetic sequences.
To define, identify, and apply arithmetic sequences.
Here's a vocabulary we'll be using in this unit. So, sequence, explicit formula, recursive formula. So pause the video and get this information down. Alright, this is the last of our vocabulary with an arithmetic sequence. Arithmetic sequence is a sequence of numbers where the difference between each number is the same, called the common difference. So read through this information, make sure you understand it, and restart when you're ready to go on. Alright, our first examples are determining whether or not something is an arithmetic sequence. So to determine if something is an arithmetic sequence, you want to see if you're constantly doing the same thing. Like in this first sequence, to get 1, to go from 1 to 3, I have to add 2. To go from 3 to 5, I have to add 2. And to go from 5 to 7, I have to add 2. So this is an arithmetic sequence. Next sequence, to go from 1 to -5, I am subtracting 4. And if I subtract 4 again, I get -9. And if I subtract 4 again, I get -13. So this is also an arithmetic sequence. But now let's look at the third one here. To go from 1 to 3, 1 to -3, I have to subtract -4. And then to go from -3 to 5, I'm adding 8. So the first time the pattern changes, you know that it is not an arithmetic sequence. And an easy way to determine what the pattern is in the arithmetic sequence is take the second number and subtract the one before it. So there's a difference of +1 here. Take the next number and subtract the number before it. And there is a difference of 2 here. So this one is also not an arithmetic sequence. Alright, let's see what happens when we do this in 5. 2.5, and to get to 3, I am subtracting. I get a -0.5. So, and from 2 to 2.5, -0.5. And from 1.5 to there, it's a -0.5. So the pattern stays the same. So this is an arithmetic sequence with decimals. Alright, now let's look at the next pattern. 1/2 minus 1/4 is 1/4. Okay, so basically I'm adding 1/4 every time. So 1/2 plus 1/4 is 3/4, and 3/4 plus 1/4 is 1. So yes, this is also an arithmetic sequence with fractions. Now look here, I am adding 1, and right here I get there and I have to have added 2. First time the pattern changes means it's not an arithmetic sequence. So an arithmetic sequence is a pattern of numbers where you're constantly adding or subtracting the same amount to get the next number. Alright, so let's see. Are these arithmetic sequences? To go from 12 to 16, I have to add 4. 16 minus 12 is 4. 20 minus 16 is 4. So it's an arithmetic sequence because this dots, dot, dot means it follows the same pattern. So to find the next 3 terms, I just have to take 20 and add 4. Take 24 and add 4. And take 28 and add 4. And there's my pattern. So let's see if you can figure out what the next 3 numbers are in the next example. So in the next example, I was subtracting 2 each time. So if you subtract 2 3 more times, you should get -3, -5, and -7. Alright, here's our formula for an arithmetic sequence. This formula is on the reference sheet that you'll get when you take the EOC at the end of the year, but it is not on the ACT. And if you take the ACT 10 times, 8 out of those 10 times, you're going to have to use this formula. So you really should learn this formula now. Alright, here's our first example where we're going to use this formula and wants us to find the 46th term of the arithmetic sequence. So you know it is a sequence, and here's our sequence here. So our arithmetic sequence formula is AN, the term we're looking for, which is the 46th term, is equal to A1. A1 is our first term, plus our common difference. What are we constantly adding or subtracting to get the next number? Times the term we're looking for, that's our 46, minus 1. So all we have to do is substitute this information in. Our N is 46. Our first term, our A1, is 3. And what we are doing every time is we are adding 2. So this is our difference. All we have to do is plug those in. I'm looking for the 46th term of this arithmetic sequence. That's what this stands for. My first term is 3. My common difference is 2. And I am looking for term number 46. So all I do is plug this information in. So 3 plus 2 times 45. And it's 2 times 45 is 90. So the 46th term in this sequence is 93. Alright, now let's see if you can use the formula and find the 121st term in this sequence. So, just so you know it, I'll write down the formula. AN equals A1 plus your common difference times the term you're looking for minus 1. So let's see if you can figure out what to plug in and simplify this. So pause the video and do that now. Alright, here's what I got, a negative 591, so the 121st term in this sequence should be a negative 591. If you got something different than me, make sure that you tell me about it and we'll talk about it in class. Alright, here's another example. It's an arithmetic sequence. All it is a word problem here. So it says the number of seats in the first 16 rows in a curved section of an arena form an arithmetic sequence. So it tells you it's an arithmetic sequence. And it says that there's 20 seats in row 1 and 23 seats in row 2. How many seats are in row 16? So what that means is you have a sequence here that starts out 20, 23, and it continues on. And it wants to find out how many rows there are in row 16. So you're going to use your arithmetic sequence formula. And our first number in the sequence is 20. We are adding 3 row seats every time, so that is our D. And we want to know the 16th row. That's our N. So if we plug all that information in, our first term plus our common difference times the row, the number of seats we're looking for in row 16. That gives us 20 plus 3 times 15. 3 times 15 is 45, plus 20 is 65. So there should be 65 seats in row 16. Alright, final thought. So you have a student that claims the next term of an arithmetic sequence that goes 0, 2, 4 is 8. Alright, the student made an error. So what is that error? And can you figure out what the next term is? So think about this. Write down what you think and we'll discuss it in class.